Hi everyone, in this video we are going to practice doing 3 different limiting reagent problems. But please note that this is a video at the very end of a 3-part series. So the first one is basic stoichiometry, the second one is more advanced stoichiometry problems, and then this is the very last one where we actually dive into limiting reagent problems. So if you haven't watched the previous 2 videos, please take a second and go back and do that to make sure that you're actually ready and your skills are up to par in order to actually do these limiting reagent problems. So let's start off with a really fun one. Just kidding, limiting reagent problems are usually not that fun, but that's okay, we're going to have fun with it today. So how many moles of methanol are produced from 13 grams of hydrogen and 13 grams of carbon monoxide? I've actually given you the chemical equation here, so go ahead and do this problem. If you did the previous video, then you should already know the mass of methanol that's produced from 13 grams of hydrogen, okay? Go. All right, did you get an answer? Hopefully you did. If you've watched this as part of our series, then you already know that we can create 3.25 moles from 13 grams of hydrogen. So what we need to do now is figure out how many moles of methanol can be created from 13 grams of carbon monoxide, okay? So we're going to start with our 13 grams of CO. We know that in order to get to moles, we need to use our molar mass, and so we can use this directly off the periodic table. So the molar mass of carbon monoxide is about 28 grams for every 1 mole. Okay, so this is of carbon monoxide. Now we're going to use our chemical equation in order to go from carbon monoxide to methanol. Luckily for us, there's a 1 in front of each one, so our mole-to-mole ratio is unbelievably simple. But we basically have 1 mole of carbon monoxide for every 1 mole of methanol. Okay, so now we just plug this into our calculator, and we can see that using 13 grams of carbon monoxide, we can only create 0.464 moles of methanol. So this is a very, very standard limiting reagent problem. We're telling you that we have 13 grams of this carbon monoxide, 13 grams of this hydrogen. How much of our methanol can we actually create, okay? So now with our 13 grams of hydrogen, we're saying we can create a lot of methanol, but with 13 grams of carbon monoxide, we can only create 0.4 moles of methanol. So this is definitely our final answer. It is the smaller of the 2 values, so we know it is going to be the correct answer, which means that our carbon monoxide here, this component is actually our limiting reagent. So we don't have enough carbon monoxide to react fully with our 13 grams of hydrogen. Hopefully that's making sense, but let's try another example just in case that's not perfectly clear. So now, same equation as video 2, but we've flipped it, so we've reversed it. Now we're taking water and oxygen to create peroxide. So let's say you have 100 grams of each. You have 100 grams of your water, and you have 100 grams of your oxygen. We're trying to figure out how much, so what mass specifically, of peroxide is created. This is a limiting reagent problem, so you need to do this for both species. Go. All right, did you get an answer? Hopefully you did. It's basically the exact same thing we've been doing in these previous videos, but you just have to do it twice. Whenever there's a limiting reagent problem, you have to do each thing for both species, which is kind of frustrating, but it's okay. All right, so let's start off with our water. We have 100 grams of water. And what we're going to do is try to take that from mass of water to mass of peroxide. And the only way we can do that is through a mole-to-mole ratio. So our mass of water needs to be converted to a mole of water. So our periodic table tells us that that 1 mole of water is equivalent to about 18 grams. So we're going to put grams on the bottom and then moles on the top. Now we're going to use our chemical equation here in order to do a mole-to-mole ratio. So I see that there are 2 moles of water for every 2 moles of peroxide. So we have a pretty easy mole-to-mole ratio here. 2 moles of water to every 2 moles of peroxide. So that's our H2O2. But this problem, is asking us to solve for grams, not moles. So we need to take this one step further. So for every 1 mole of peroxide, which is our H2O2, we know from our periodic table that we have about 34 grams. So if you solve this properly, you end up with a value of about 188.94 grams of peroxide that can be created from starting with 100 grams of water. So that's what we know we can do with 100 grams of water. Now we want to know how much we can create with 100 grams of oxygen. So remember, when you're doing a limiting reagent problem, you're looking for the smallest amount of product, okay? It doesn't matter if you can make 1 billion grams of peroxide if the other reagent can only make 1, okay? So that's what we're trying to figure out. So we literally are going to do the exact same thing, but with oxygen now. So for 100 grams of oxygen, again, we use the periodic table to see that the molar mass is about 32 grams for every 1 mole of oxygen. Then we're going to use our mole-to-mole ratio. So for this one, it is different. We see that there's 1 mole of oxygen for every 2 moles of peroxide. And then again, we're going to use the molar mass. So we have for every 1 mole of peroxide, we have about 34 grams of peroxide. And if we put this in our calculator properly, we end up with a value of about 212.56 grams of peroxide. So here are our two options. With 100 grams of water, we can make about 188 grams of peroxide. With 100 grams of oxygen, we can make 212 grams of peroxide. So this number is significantly bigger, which means it's not the right answer. So our correct answer is definitely this 188.94, which means that this 100 grams of water, that's our limiting reagent. Okay, that's the one we have the smallest amount of. We cannot make 212 grams of peroxide because there is not enough water. Okay, so hopefully that's making sense. Let's do one more. Okay, last one, and then hopefully we'll have this all down. Good luck. All right, did you get it? It's our last problem of this 3-video series, so my fingers are so crossed that you were able to just absolutely nail this one. So please, please, please tell me you got it right. Okay, hopefully you did, but let's work through this together. So the first thing you need to do is decide which one you're going to start with. We know we have 1 gram of methane and we have 3 grams of oxygen. We're trying to figure out our mass of our water, and so we need to take each of these species and convert it to our water component. So let's start with methane. So for every 1 gram of methane, again, we have to go from grams to moles, so we know from the periodic table that there's about 1 gram of methane for every 1 mole of methane. We're trying to take methane to water, so we need to use a mole-to-mole ratio. We see for every 1 mole of methane, we see 2 moles of water. Okay, we're trying to go to water, so that's why I picked water here, 2 moles of water. And then we're trying to figure out a mass. We need to take this one step further. So for every 1 mole of water, we have 18 grams. If you put this in a calculator properly, you end up with something like 2.25 grams of water. Okay, so if we have 1 gram of methane, we can create 2.25 grams of water. Let's do the same thing for oxygen. So we started with 3 grams of oxygen. By the way, sometimes this trips people up for some reason. If you have a 1 gram of one and 3 gram of another, if they're not the same starting quantity. So just make sure you're very, very specific and take good notes and just write down. Make sure you just don't mix anything up. Go slowly through these problems, okay? All right, so for 3 grams of oxygen, we need to convert oxygen to moles. We know from the periodic table that there's about 32 grams for every 1 mole of oxygen. And then from looking at the periodic table, we see that there's 2 moles of oxygen here for every 2 moles of water, so it's a pretty simple mole-to-mole ratio. Last step here is the same step as for just directly above it. We see for every 1 mole of water, there are definitely 18 grams. Okay, if we put this in our calculator, we get an answer of 1.6875 grams of water. So if we look at our two answers, we can definitely see that this is the smaller quantity of the two. So from 1 gram of methane and from 3 grams of oxygen, we can only create 1.687 grams of water. We cannot create 2.25 grams because we do not have enough oxygen. So what does that actually mean? It means that our 3 grams of oxygen is our limiting reagent. We can create 1.6 grams of water, and our 3 grams of oxygen is our limiting reagent. Oh God, I hope this all makes sense now. If it doesn't, you need to go back and figure out where your holes are, where the misconnections are, and just do these problems over and over and over again until you don't make a mistake. Once you're at that spot, then you're ready to tackle the exam. Please do not do one of these problems, get it right, and be like, oh, I'm ready. Like, that is not what a college student does, okay? You have to drill it and drill it and drill it until you're 100% perfect. Good luck. Have a perfect week. Take care of yourself and drink water.